I'm Rogier van der Weijer. I'm International Business Development Manager for Blue Phoenix Group, and I'm honored to be on your webinar today on the valorization of incineration bottom ashes for use in construction, for use of the aggregate in civil engineering. And I would like to present you Blue Phoenix Group, what we have developed, what we have done in the past, and some forward-looking statements. Let me share my presentation with you, which I have prepared for today. So, building a sustainable future with bottom ash aggregates, a technology and best practices overview. In this presentation, I would like to introduce our group, specifically speak about the legal drivers and the technology choices which are accompanying by that. Talk about the processing technologies, talk about removal of contamination and going into depth into some specific contaminations, the various technologies that we have developed, wet and dry processing. Then something we really bring to the table is our environmental control mechanism to assure a safe use of these aggregates, and speak about the application areas where the IBA aggregates can very well replace primary materials. But first, let us zoom into where we are in the whole waste management cycle. As a group, we are not investing in energy from waste itself. We come afterwards, and we work with the ashes that are produced during waste incineration. And then we process them, and within our group, we have the Blue Phoenix labels that are concerned about the processing. And we have the metal refinery that is further upgrading the metal qualities into smelter qualities. And obviously, we have a whole department that deals with the sales of the aggregates and to assist civil engineering and road construction companies and concrete products companies with how to apply them at best and to make sure that these aggregates take their position to replace virgin material. For that, we say Blue Phoenix Group, building a sustainable future. We are maximizing the recovery from this urban mine ash, both from the perspective of minerals and, of course, some value extraction with respect to metal recovery. We are a truly global player. We have our business in Europe, UK. We have made a step across the pond to the United States and Asia. And recently, we also have invested and are constructing our first ash processing platform in Perth, Western Australia. Below you see some labels, Semperk and Cure Metals and Elementals, that are labels within our group. The metals company is obviously our metals refinery business, and Elemental has a specific technology to remove a specific type of metal, zinc, focusing on zinc. And Semper is our new business line, which focuses on a mineral aspect. Later on in this presentation, more about that. To date, we are about 450, maybe already 500 people strong. We operate at various locations all over the world, and we process a magnitude of 4.5 to 5 million tons of ash on an annual basis. Okay, let me have a look at the role of energy from waste in this economy. Initially, we have a linear economy. And ideally, we want to go up to the circular economy. But for doing so, our Frans Timmermans, the European Commissioner, has said by 2050, most countries follow that, by 2050, we want to be fully circular. My calculation says then we have another 28 years to go before we get there. So we definitely need energy valorization as an alternative for the non-recyclables. And let us put an aim on this sheet where we say, if you want to reach 60% recycling, already quite a high target, but let's aim high, That still means we have 40% non-recyclables, which we label as non-recyclables, but we can very well use them and should put them to the energy from waste facility. And to get to 100%, we have to change our economy and we have to design products which are really suitable for recycling. So my point here, in the coming 25, 30, probably longer years ahead, we need energy from waste, and therefore you need companies like Blue Phoenix Group that can assist this market with creating products out of this non-recyclable portion which has been incinerated. And if you look to the incineration ashes, there is minerals and metals. That's the majority of the components that are non-burnable, so reside in this ash. And these mineral aggregates we can very well use in road construction or to replace primary materials in concrete products. And then we have important, although limited in volumes, interesting in values and interesting in value addition, is the ferrous and non-ferrous metals, which find its way to the steel market and to computers, electronics, cars, etc., helping to reduce depletion of the earth, because there's so much material we have already used. And the nice thing about metals is they can be smelted infinitely, so we can really reuse them. That's our position. We are a typical niche player company, but we do that on a global scale, and we have all the skills and needs and experience in our group to assist the energy from waste sector in building a sustainable future and closing the loop, and to avoid landfilling of these valuable residues. Okay, then on to, let's say, the topic of today. We would like to use the IBA aggregates in civil engineering, but we can't do that just as is. So we really have to process them, but much moreover, we have to look at how can we use them and how can we use them safely in the long term. So we have to look at the composition, what contaminations are in there, unburned organics, chlorides, bromides. Then we have to look in where are we, what is the legal possibility of using this product. And there's many countries that have still linear legislation, and we have to look at, can we really use this? Is this allowed, and how is this allowed? And there we see you can use it still as a waste, being a product, or going to the highest level of declaration of end of waste status for the product. So from a legal status, we have to look, but much moreover, we have to look at two more aspects, which is the environment aspect of it and the technical aspect of it. So can it be done? How can it be done? How does it behave? How does it behave in the long term environmentally? And how does this work for a concrete product manufacturer or a road construction company in its civil engineering specifications? How's the load bearing? How's the compaction? How is it working in the product matrix? And that's where we come in, both from the angle of processing to a certain quality, but also assisting these off-takers of the product. And I'm speaking about the aggregate product. Metals find its way to the metal smelters. That's fine. But the aggregate product, we really can bring knowledge to the table to help this market in how to use this in a proper manner. Let me first zoom into the legal compliance discussions. There's actually not left and right or good or bad, but there's two ways of looking at it. And I'm from the Netherlands. Here in the Netherlands, our government has chosen to look at a uniform IBA quality specification, meaning that you have to specify, or you have to comply with a certain quality, quite strict limits they have set. But once you reach that quality, it can be used freely without further restrictions all over the country, even in residential areas, in groundwater winning zones, etc., etc. The other side of the spectrum is much more looking at the quality as is. What is the quality, and what does that mean? Where can we use that? both systems have good and bad points. If we look to the uniform IBA quality specifications like we have in the Netherlands, we have set one limit suitable for all, meaning it probably, and because we have one meaning for all, it is quite strict, and probably it's quite strict and maybe even too strict for certain usage, meaning that we have overprocessed and overspent energy to come to a certain quality. And probably we have done not enough for some other specifications where you should have said, maybe we should not use it in that manner. More used, what we see in all over the world is the restricted use, and looking at typical location aspects, so looking to local hydrogeological elements and the data and the soil conditions of where you are going to use it, the soil conditions, the residential conditions, etc. And then we look at, okay, can we use it here, and what if scenarios? So that gives us the case-by-case analysis in which we can optimize the result for use or non-use. That brings some complexity. On the other hand, it brings also security for each individual use. Whereas the uniform specification is nice, is good, is quite a strict limit. However, the costs of that and the energy spent to that might nullify all the sustainability benefits by using circular secondary materials, because you are really increasing processing. On the other hand, this is the method in which we for sure know that we can use it in a wide variety of applications. Not good, not bad. This is just an overview of the two systems we face and we see. We can reach this quality both, we can reach this quality for the uniform specification for the Netherlands with dry processing and with washing. Washing is more and more popular, and as a group, Blue Phoenix has invested in a large washing facility and washing technologies. We have created the dynamic intense washing, and we deeply can remove soluble and non-soluble contaminants. And due to the fact that we process this material in a wet manner, also metal recovery reaches very high quality aspects and recovery rates. You can also reach that with dry processing. However, you see that in dry processing, you are not washing any chemical contaminants. So you can concentrate some of the highest contamination in fines and put those aside, or put them either to landfill or immobilize them in a bound manner, and we can use the aggregates. So again, not good, not bad. I would like you to remember, Blue Phoenix Group serves this industry. We have a whole suite of technologies that serves this purpose. And we can help the industry wherever you are on the world. An overview of some processing sites we have. We have indoor sites, outdoor sites, we have mobile equipment. And we have, as I just said, we have developed a large washing facility in which we process the IBA from the input in a wet manner. But that brings a high burden on water treatment, water purification, and water processing. We are not discharging any water, so we have a huge capacity and a huge installation to recover the processing water, to clean the processing water, and to make sure that no water is discharged or no contamination are discharged. And obviously, you cannot just get rid of any contamination. If you wash them out, you will concentrate them, like with the dry manner, you concentrate them somewhere. So you either have to define whether you discharge that in the case of washing the sludge, or immobilize them in some manner. But again, we do have these technologies. And on both sides, we work with off-the-shelf technology. We are not going to reinvent an eddy current or a magnet, but we do have patents in this washing equipment, and we do have patents in dry separation, in ballistic separation methodology, which we can put to the table. So some specific contaminations we wash out: chloride, sulfates, copper. Where does it come from? From plastics, from gypsum, from organics, from fire retardants, more and more, from humic acids, from fines. And then two categories, the last two, level of unburnt and level of batteries, not specified in Dutch soil conditions or in Dutch soil degree. However, we have put ourselves a target of just less one battery in a ton of material to make sure that we are not spreading contaminations. Batteries do not belong in the environment, although you and me, we are so now and then a bit lazy, and batteries do end up in household waste, unfortunately. Okay, looking at the available technologies, there's many. Processing installation is not just one machine, it's already a line of equipment: seizing, screening, sizing, screening, magnets, eddy currents, and in the case of washing, we want to we have the problem of soilable material, which you have to wash out. So we wash with log washers, with washing drums. We use cyclones to purify the water. We use microfiltration. We use reverse osmosis. We use evaporation. But for something relatively simple as battery removal, we just need a lot of magnets and a lot of fractionizing to make sure each fraction has had the right processing. A picture of one of our sites, in this case in France. On the back side, you see the ballistic separator, the ballistic methodology, and on the front with the covered conveyor belts. That's an eddy current frame with a multitude of eddy currents to make sure the fines are run over a cascade of eddy currents to maximize this material. Then zoom in a bit of how this ballistic technology works. In the left top corner, you see a rotor device, and that's the basic element. The ballistic separator is not on its own. It's in fact, you have to look at it as a preprocessor to make sure that an eddy current can perform its task, and it accelerates material, and therefore fine elements accelerate fast and get rid of their adhering stickiness. So the real trick is to concentrate real fine elements, smaller than a millimeter, smaller than half a millimeter, which are concentrated with the coarse material because they are relatively heavy. And the real fine minerals, the sticky, the humidity, the fine, the dust is getting rid of. So on the eddy currents, you have freely material that is running by itself. A small demonstration. On the left side, you see material that has not been run over this ballistic separator, and to the right side, material that has been processed by this ballistic separation, that the sticky fines are gone. And you see to the left, rather than screening efficiently, it compacts, it agglomerates, and it brings a lot of issues. Moving on to the washing technology. Equipment due to a short overview, and let me run this film. Here you see the dirty wastewater, but it's cleaned by whole processing of water, so we can use this nice fresh water that we discharge filtered cake from the filter presses. Okay, that's going to landfill as it has the concentration of all the contaminants. We are looking into research it, but only 2% of this material, and therefore it unlocks all the rest of it as a proper act. This stockpile can really replace materials that are virgin materials. Then on for the last minutes of my presentation to what we further have done. We can use materials anywhere we like as layers, sub-base layers for road construction, in industrial flooring, in footpath, in pipe bedding. But as a group, we also have done something specifically. We have added geohydrological modeling to the table, in which we look at the soil conditions where has been used, what is the quality of the material, and we model 100 years ahead the risk of contamination in groundwater in certain areas. We call that our source pathway receptor model, in which the source is known, the pathway, whether it's used in clayish area or in sandish area, what is the potential leachate that can reach the aquifer, how is the dilution, how is the transportation of that potential contamination, and in 100 years, how does it get to where, and if that is a danger, or if it's just accepted by dilution and natural processes in our water systems. So we bring that to the table to assure a safe use. And then also looking into the future, we as a group has added technologies to IBA processing. We have come up with this ballistic separation to optimize dry processing. As a group, we have invented IBA washing and the whole washing technology behind it to make sure you're not discharging too much water. And our next step, I said it with the logos, Semper, one of our future elements. We are simply saying using the pozzolanic characteristics of the material by grinding it to a powder, and that powder has cementitious characteristics, really being able to replace not only the aggregates in concrete products, but also now replacing the cement, which is one of the highest pollutive industries, highest carbon emission industries. And if we can replace that, we can really claim our statement, building a sustainable future. So some of the elements, IBA-A, the aggregates versus primary aggregates, it's a good material, it's a light material, it has lots of benefits, it has about 20% less CO2 emissions compared to using primary aggregates. So really starting to become a sustainable aggregate for use. We care about the climate, we care about the circular economy. We are a live example of dealing with this material in a proper manner. And I'm very open to questions and look forward to speaking to you in a short future and discussing our contribution to this industry. Thank you very much for your attention. I'll be happy to answer questions right now or later. I let that decide by the moderator, and would love to see you in a personal meeting or invite you here at one of our sites to show you what we can bring to the table. Many thanks for your attention. Really looking forward to future personal meetings.